Welcome to the Healthy Skin Show with Jennifer Fugo, where we're flipping everything you've been told about your chronic skin issues upside down and connecting you with alternative solutions your dermatologist never told you about.
Welcome back to episode number 181 of the Healthy Skin Show. In today's episode, we're going to be talking about an article that I found online with the headline, "The Probiotic That Kills Antibiotic-Resistant Bacteria." This article, found in Medical News Today, was actually based off of a study that was published in Nature. And so one of the really cool, interesting things was that the research that this is referencing was able to show that, quote, a type of probiotic bacteria called Bacillus is able to fight and effectively eliminate Staph aureus, end quote. And I went on to continue to read the article and saw a very familiar name, specifically Bacillus subtilis. And for those of you who might know or have an inkling of where you've heard that type of probiotic before, stay tuned because my guest today is an expert when it comes to Bacillus subtilis and other spore-based probiotics. My guest today is Kiran Krishnan, and some of you may recall he was actually on some of the first episodes of the Healthy Skin Show over 2 years ago. We both acknowledged that 2 years is too long. I promise I'll definitely have Kiran come back sooner. But for those of you who are just meeting him for the first time, Kiran Krishnan is a research microbiologist and has been involved in the dietary supplement and nutrition market for the past 18 years. He comes from a university research background, having spent several years with hands-on R&D in the fields of molecular medicine and microbiology at the University of Iowa. Kiran established a clinical research organization where he designed and conducted dozens of human clinical trials in human nutrition. Kiran is also the co-founder and partner of New Science Trading, a nutritional technology development and research company, and he is the co-founder and chief scientific officer at Microbiome Labs. He is a frequent lecturer on the human microbiome at medical and nutritional conferences. And he is an expert guest on national and satellite radio, has appearances in several international documentaries, and has been a guest speaker on several international health summits as a microbiome expert. He is currently involved in 16 novel human clinical trials on probiotics and the human microbiome, and he also is on the scientific advisory board as a science advisor for 7 other companies in the industry. So to say that Kiran knows his stuff is really an understatement. He is truly a pleasure to talk to every single time I have interviewed him. I've had the pleasure of meeting him in person, and he is just as wonderful and warm in person as well. And I am thrilled to have him back today to talk to us about this amazing research. So let's dive in. Kiran, I just have to say I'm so excited for this conversation, and I'm also incredibly appreciative to have you back on the show. It has been almost 2 years since you've been back on the Healthy Skin Show, and I was trying so hard to make this happen. You're a busy man, but I am so grateful that you were able to make time to be here because the conversation we're having today, I think for many people listening, and look, staph issues are not specific to eczema. I want to be very clear with everybody listening because a lot of times people just think it's eczema is the only condition that can result in staph infections. But I have seen staph infections in people with psoriasis and other skin issues. And so the fact that there's some interesting interaction between certain probiotic strains and staph, I just thought people had to hear more about this. So thank you so much for joining us and sharing about this today on the show.
Of course, it's my pleasure, and interesting to note that we finally got to meet in person, right, for the first time.
Yes.
It was about a year ago.
That is true.
Right?
At the Integrative Healthcare Symposium, yes.
In New York. It was actually one of the last conferences I went to one other after that, and then the whole world ended, right? So
pretty much
there were no more conferences.
Yeah,
so
nope.
it was. I was very Kelly. I was very glad to be able to meet you finally in person, and
Yes.
very excited to talk about this topic. So thank you
I
for having
know.
me.
So why don't you take it away with what exactly are we talking about here in terms of staph and probiotics? Like the reason I reached out to you specifically because when I saw this paper
Hmm.
and they mentioned bacillus species,
Hmm.
specifically Bacillus subtilis, I was like, wait, hold on a second. I'm pretty sure this is in Megaspore.
Hmm.
And I looked and I was like, wait, hold on. Kiran is probably the best person to talk about this. So can you share a little bit about the research that's been done initially around just talk to people about it so they have some idea of or grounding around this conversation and where we're going to go with it.
Yeah, one of the risks that I think most World Health um, organizations, whether it's the NIH, WHO, all of these big research organizations in the world, one of the big issues that we see coming up is that we may soon live in what's called a post-antibiotic world, right? The discovery of antibiotics, penicillin early on was a real game changer in the world of medicine because it allowed people to not die needlessly from simple infections, which can go awry pretty quickly. But of course, being humans, we've taken and abused that. And we overuse antibiotics like crazy, whether it's on humans and animals and cattle. And what we've done is we've created lots and lots of antibiotic resistance out there. And by many measures, that is one of the biggest global health risks that we face because we are reaching this part of a post-antibiotic world, meaning that there are prevalent pathogens that cause problems for all of us that cannot be controlled by the use of antibiotics, right? So there's two approaches to that. It's let's keep finding new antibiotics, right? Which is really a difficult thing because the economic incentives to find antibiotics is really low. Most pharma companies make little to no money on antibiotics, and so they have no economic incentive to actually look for new antibiotics. And then, or the second option B is understanding what's going on with the microbial ecosystem where bacteria actually can control other bacteria, and they do it way better than we do, right? And that happens in the natural environment, including our body. So that was the impetus for this NIH study. So the National Institutes of Health, in fact, it's the Division of Infectious Disease and Allergies. That's the big division we've all been hearing about in the last 12 months because it's headed up by Dr. Anthony Fauci. Right, so it's one of the most well-known and well-regarded research institutes in the world. They conducted this study with partnership with a research group in Thailand, looking at MRSA. So MRSA is methicillin-resistant Staph aureus. That is one of the biggest risks that we have out there as an antibiotic-resistant pathogen because it's relatively common. It is most people have some degree of colonization of this organism. It can get onto places like your skin, and if there's ever a little break in your skin, it can get in and cause all kinds of horrific infections. It can sit dormant in your nose, in your gut for a long time without causing any problem. So you may not know you have it until something happens like you wipe your nose with your hand and then there's a little cut on your hand and then you get a massive infection that's absolutely life-threatening, or you have a certain amount of it on your skin that can trigger inflammatory responses that lead to things like psoriasis, eczema, or you can pass it on to each other, right? This is a very transmissible organism. So from, a guest that comes into your home and uses your shower may leave some MRSA in your shower, and then you pick up their MRSA the next time you go into your shower. So it's in locker rooms, it's in all kinds of places where people congregate and get together. And the big problem with it is it's called methicillin-resistant Staph aureus because it's resistant to the vast majority of antibiotics. And then there are subspecies of MRSA that are even more resistant because some MRSA is susceptible to some small classes of antibiotics still, but then we're finding new species that are actually resistant to everything, right? So if you get that kind of infection, the likelihood of coming out of it is significantly reduced. So then the question was, are there organisms naturally that are found in the body or in the environment that can combat the presence of MRSA. So they did this study in Thailand where they sampled 200, little over 200 people. They sampled a bunch of sites. They sampled their stool, they sampled their nose, they sampled their skin. And what they found was that in people that had colonization by MRSA, they were missing Bacillus subtilis as a normal colonizing organism in their system. But those that had no MRSA, the only difference between them and people that had MRSA was that they had Bacillus subtilis. So if you had Bacillus subtilis colonization in your body, in your gut, in your nose, and other areas, you were absent of MRSA, right? So that was found in humans. Then they took it a step further and they said, okay, this is correlative, right? We can see that if you have subtilis colonizing, which is of course our main strain that we work with. I've been working with subtilis now 15 years, I think. If you have subtilis, you don't have MRSA. Is there a mechanism by which subtilis combats MRSA, right? So that's what they wanted to find out. So then they went into animal studies and infected mice with MRSA, and then also incorporated probiotic Bacillus subtilis, and then saw if the Bacillus subtilis could fight off the MRSA. And basically they found that it does. And the way that it does is Bacillus produces a number of compounds in your body. Lots of them have tremendous benefits, but one compound they produce is something called fengicin. Fengicin is a lipoprotein. It's a lipid, and it's a lipid meaning a fat and a protein. So it's a combination of lipid and protein. It's a very unique molecule. And what it does is when it's squirted into the environment, in the ecosystem, it interferes with the signaling that MRSA has, that MRSA requires in order to grow and propagate. So then the bacteria end up dying off because it basically confuses and attenuates the metabolic signaling that MRSA is supposed to have. So
that's very smart, by the way.
Right?
That is a really ingenious
We can't
mechanism.
create things like this, right? This is nature at its best, right? This is microbes protecting the host, which is us, fighting against things that microbe knows is harmful to the host, right? Think about this. When you think about that, we've got hundreds and hundreds of species in our system, the vast majority of them beneficial or benign to the host, right? And one of those species is Bacillus subtilis. This bacteria has figured out a compound that it can make that interferes with a pathogen, but doesn't interfere with all of the commensal important bacteria in our system, right? We cannot do that. You could give me the 100 smartest microbiologists in the world with an unlimited research budget. We can't do things that are that precise, right? So this is nature at its best, and what we have to do as a species is start to study these things, appreciate them, and then utilize it. So now they've done a few iterations of that study where they either colonize the mice with Bacillus subtilis and then introduce a MRSA pathogen, and then it basically wipes out the MRSA pathogen in different sites in the body, or they would cause an infection with MRSA and then introduce the probiotic, and it eliminates the infection. So now the next steps of the studies that are being done is, can we eliminate this pathogen from hospitals, right? Can we give Bacillus subtilis as a probiotic to every patient that's coming into the hospital so we eliminate the threat of MRSA in hospitals and nursing homes, places like that where it just rears its ugly head and causes major outbreaks and a lot of suffering in people, right? So.
And I want to add to this too, just from my clinical experience. So people who tend to have eczema, though I do see this in other stool tests as well, they do tend to have high Staph aureus in the GI tract. And so a lot of times people think, well, I have a skin issue. It's just on the skin, but there's this disruption that I tend to see as well in the gut microbiome.
Yep.
And that tends to be one missing piece. Can you speak to a little bit about that? Just any thoughts on that of like, I know we've touched on this before, but I think given this conversation, and obviously you haven't been on in 2 years, so you probably have more things to share.
Yeah.
Why is it that someone who may struggle with staph on the skin could potentially end up with it inside their GI tract? Is there a significance to that?
Yeah, in fact, it's likely the reverse. It's likely it started in the gut and then now it's ended up on the skin, right? And why is that? Well, the fact of the matter is, the dirty secret is your poop ends up everywhere in your house, right? On your skin, in your mouth, in your nose, on the walls. It sounds crazy, but it does. Let me explain a couple of mechanisms, right? Number one, when and this is when you're doing training as a microbiologist early on. One of the first studies you get to do is actually going around and swabbing things, right? You get to swab things, plate it, grow it, and see what grows. When you swab things like doorknobs and light switches, actually the absolute grossest place, which is worse than most toilets, is the little finger holes in bowling balls.
Oh.
Yeah, absolutely gross. And I go bowl. My kids love to go bowling and so on. So we've gone bowling, and I can't tell you how many times you see people bowling. They throw the ball, they come back to the table, they grab the nachos, right? You're eating a sandwich. The finger holes in the bowling ball are worse than a toilet because it never gets flushed. It just keeps getting poop in there, right? So the fact of the matter, and it's an unfortunate thing. And then here's the other thing:
is.
when you go to the bathroom, right? You defecate in the toilet and you flush, right? And that vortex of the toilet is spinning. That's going to aerosolize a bunch of your fecal bacteria, and then your air intake system is going to suck it in and then blow it out through the rest of your house, right? So you've got poop everywhere in the house. Okay.
This is a horrifying image, I have to be honest, but
it is, right? It is. But here's the thing. What you don't need to do is you don't need to go, holy crap, we got poop all over the house and start Cloroxing the walls, right? That's not the message here. The message here is having poop all over the house is actually a good thing if your poop is healthy, right? Because that creates a healthy ecosystem in the environment, right? On your surfaces and on the in the food and in the cups in the cupboard and all of these things.
And we should be able to some degree to be able to live in harmony, I would say, with microorganisms, right? Because that was part of the problem where we started becoming overly clean.
Yeah.
And now all of a sudden we can't tolerate certain species.
Yeah, and it's not that we should. We have to live in harmony, right? That's part of how we're designed. We are a microbial construct. Most of our system is microbes, right? We have more microbial genetics, about 150, 200 times more microbial DNA in our system than human DNA. We have more microbial proteins. When you look at cell count, we have more microbial cells than human cells. And every square millimeter of our body, including our skin, is covered with microbes, right? So for every single skin cell on the surface of our skin, we've got about 30 bacteria cells, right? And so when you look at dust in your home, what is dust, right? 90% of the solid matter of dust is skin cells, human skin cells, right? And it's 30 times that amount bacteria. And so we are exchanging microbes with people that are within our area, within our office, within our car, our workplace, in our home, including skin bacteria, poop bacteria, oral bacteria. All of those things are constantly coming out of the body. And so if you're colonized with MRSA, at some point it's going to get on surfaces that's around you, and then it's going to get on your skin, right? And if your skin is already weak and compromised, right, your skin is dry, it's thin, it's got a lot of little micro lesions and micro cuts, the MRSA is going to make its way into the deeper recesses of the skin and actually set up shop. And that's where it can rear its ugly head. And then at the same time, if your immune system is not tuned to detecting and dealing with MRSA, then you're going to have a hard time dealing with it on the skin as well. So there's a secondary benefit to what things like Bacillus subtilis do in the system. Number one, we just described how it can directly target MRSA, right? But the other thing that beneficial probiotic bacteria like that do is it trains your immune system to deal with these pathogens as well, right? It creates recognition systems for your immune system to identify MRSA, know that it's not beneficial, and then in fact develop mechanisms to deal with it. So when you've got MRSA in your gut and it's allowed to sit there and colonize and breed for a while, you've got no immune defense against it, and you don't have the competitive bacteria that are working against it as well. So now it's in your gut, it's going to come out, it's going to end up on your skin, it's going to end up in your eyes, it's going to end up all over the place, right? And we're going to transfer it to one another, and it'll start causing problems for some people.
May I ask, because I think people might be curious about this. So Bacillus subtilis is just one, that's just one bug. There are
Mhm.
other forms of Bacillus.
Yeah.
Is this really specific, this whole topic about Staph aureus, is it specific to Bacillus subtilis? Do other Bacillus strains also help, or is this just seem to be the one? Because you're like Megaspore, for example, has a combination of
Mhm.
different spore-based probiotics. I think the other thing too is a lot of times people don't understand that spore-based probiotics do a lot of different things that sometimes other regular bacteria just don't.
Yeah.
There's some really cool benefits to having it, and that's why I use it in my practice. But what are your thoughts on other Bacillus strains?
Yeah, so there is evidence that some other Bacillus species can also perform some of these functions, like clausi, like Neformis, also which we have within our product. Bacillus subtilis is the workhorse of what we call competitive
Mm,
exclusion. So
okay.
competitive exclusion is one bacteria excluding the growth of another by competing with it in a number of different ways. Bacillus subtilis has been shown to have that capability with a whole host of pathogens. And in fact, we're doing a number of studies in that area to understand with Megaspore what are all kinds of opportunistic pathogens that it can fight against. We'll have a paper coming out on that hopefully before the end of this year, where we worked with a group, I think, in Norway, to do a bunch of studies that mimic the gut. And then we added a bunch of pathogens into the gut, and then we added the Megaspore in there, and through a number of different iterations, you watch and see how the spores in Megaspore, which of course includes subtilis as the largest concentration, compete with those microbes. And they do it
Mm,
differently with different microbes. We published a study that was done at Cleveland Clinic last year. So this is one of the studies we published on how the spores compete with C. diff in the gut, right? So this is a really interesting way because C. diff, Clostridium difficile, is one of the other organisms that can form spores. And Clostridia, especially clostridial pathogens, tend to be pretty robust and difficult to deal with, right? Difficult to treat with antibiotics. That's why C. diff is a very major problem within the hospital system. I think it's still the number one what we call nosocomial or opportunistic infection that happens in the hospital. And tens of thousands of people die from it each year. So there's a lot of attention on C. diff and how can we control it because we don't control it well with antibiotics. And so we did this study with Cleveland Clinic where they were able to infect mice with Clostridium difficile infected with pathogen. And then we added in Megaspore, the 5-spore mix. And what they were able to show is that Megaspore does inhibit the growth of that pathogen. But the way it does it is really interesting. The spores actually surround the Clostridia. So it's almost like wrapping wagons around it, quarantining it in one specific area, and then it competes for nutrients from the Clostridia, in particular iron. So one of the things that Clostridia need in order to conduct its metabolic effect is it requires iron. That's part of why it makes your gut bleed. It's trying to get more blood into the surface of the mucosa. And so here are the spores just stealing the iron away from the Clostridia and starving it to death, right? But it's not doing that to the other commensals around. It's doing it just to the pathogen, right? So that's the part that is so fascinating. And we are trying to learn a little bit more about how these important commensal probiotic bacteria, how do they distinguish these pathogens from your commensal bacteria? What is the languaging, right? We know that the general idea is called quorum sensing, where bacteria can read other bacteria's signature. But if we can understand that language to a certain degree, it can be extremely powerful in understanding how to control pathogens, right? Because these microbes do that, right? They know how to hone in on the problematic bacteria while not disrupting the beneficial bacteria, and in fact, even enhancing the growth of the beneficial bacteria. So Bacillus as a whole, as a genus as a whole, tends to have that kind of capability.
Because Kiran is so filled with amazing information that he's so willing to share, we decided to cut his episode so that way we could have 2 parts, because it did run long and I wanted to make sure that you guys really got the nuts and bolts of this half of the conversation, because it is a little bit on the complex side, but absolutely fascinating. And if you're interested in learning more about Kiran or Megaspore, or you want to grab some Megaspore, you can head on over to getmegaspore.com and grab either Megaspore or one of the kits that we have that combines Megaspore with 2 of our top Quell skincare creams so that you can support your skin from the outside in and the inside out. Again, those are available at getmegaspore.com. And if you're interested in taking a look at the research that Kiran and I have been discussing, head on over to skinterrupt.com/181. That way you can take a look at that research and leave your questions and comments there so we can keep the conversation going. I promise you the second half of this interview will be in the next episode, so stay tuned. And if you know somebody who's been struggling with staph infections, this could be an amazing episode to share with them. And before you head off for your day, make sure to head on over to your podcast platform of choice, rate and review The Healthy Skin Show, share why you love the show. Maybe it's even just this episode that you really, really love. And then hit the subscribe button. That way you never miss out on new research, inspiration, and hope that we share here on the show. Thank you so much for tuning in, and I look forward to seeing you in the next episode.